Day 29, page 712, problem number 35. This particular section of a circuit, it's not quite like as bad as some of the ones we've done before, where it's all kind of jumbled up like spaghetti, but it's not in its conventional form here. And I'm not going to do this problem conventionally. I'm just going to kind of look at this one and do it because it's fairly straightforward. For example, you look for easy parts. We're looking for the overall resistance between points A and B, but if you look at the 1 ohm and a 3 ohm resistor near the top here, those are in series with each other. So together up here we have 4 ohms. So the 1 and the 3 together is 4 ohms. And that's in parallel then with the 4 ohms right below it. So bottom line, this 4 and this 4 together in parallel, when you have two that are identical in parallel and you apply the rule for combining resistors in parallel that are identical, it comes out as a total of 2 ohms of resistance. So those together will be 2 ohms of resistance. And likewise, the 8 and the 8 together over here are in parallel with each other. If you look at it for a little bit, you'll see that. And you combine those, and you're going to get 4 ohms of resistance for the combination of those two. So as you notice here, I'm not going to be drawing all the various diagrams step by step here, because this one's fairly straightforward. Now that combination of the 8 and the 8 that makes 4 is in series with the other 4 at the bottom. So now what I'm going to do is I'm going to combine the two 4s in series to get 8 ohms. And then likewise, the 6 ohm resistor is in series with the other 2 ohm resistors. That was the combination of the 4 and 4. So bottom line on this over here, that's going to give you 8 ohms. So what you're ending up with right now is an 8 and an 8 in parallel once you combine all of that. So the total final step is to combine the 8 and the 8 in parallel. That gives you an overall of 4 ohms. So the final answer between points A and B is 4 ohms. They gave us a bunch of easy numbers. If the numbers weren't all equal like that, you'd have to do a little bit more calculator work. But that one's fairly straightforward once you look at it and analyze it. Total resistance, 4 ohms. And now we have to figure out how much power. Well, you can figure out the current, V equals IR. 20 volts applied, I times 4 ohms, overall resistance. Current is 5 amps. So you can do P equals VI or P equals I squared R, which is my go-to equation. So P equals I squared R for the power, or VI. Oops, I squared R. So it's going to be 5 squared times 4. 25 times 4, which is 100 watts. That's the power dissipated in the whole circuit. It'd be more of a challenge now to figure out how much power was dissipated in each one of the resistors. That would have required us to draw all the particular diagrams step by step, unless you're really, really clever. But they just asked, fortunately, for the overall power dissipated in this circuit, 100 watts.